This is your current speed. This is the time that the centrifuge has been running. And then this is the actual tub temperature of the actual centrifuge at the moment. You have the vent open and closed, so that's open now. And then it's starting to run the vacuum pump. And then you have stop here. If the vacuum's open, you can actually open up the tub itself just by pushing this here. So that opens the tub. You'll hear a little chime when the vacuum's done, as you just heard. If you try to hit start, the vacuum pump starts running here. It's not gonna allow you to actually open this as well. So if you were to look down inside the tub, like you have, this is gonna be your actual heat source. This is designed just to maintain the temperature inside the tub there. This is the thermocouple module that actually reads this. This is the actual thermocouple itself. So this is just the acquisition board essentially for that. But this is the actual thermocouple that reads the rotor temperature. This right here is your strobe light. This is your LED strobe light. So this is what's going to strobe underneath your bucket. And this is your sensor that actually reads the speed. So this is going to read that little cutout inside or on the disc on the rotor itself. And then this is obviously your spindle. This right here, this sensor is where Beckman reads. So if you look at the little sticker on the back of the bottom stem of the rotor, that's how Beckman reads it. So that's going to be on the Beckman software. You'll read it there. This right here is a plate. So this is what the centrifuge will actually read, is this plate down here. And then underneath here is the heating and cooling peltiers for the actual Beckman centrifuge itself. So Smart Centrifuge right here is the actual software for the centrifuge itself. So if you double click, you will get the Smart Centrifuge software. So the first thing you're going to do is, this is kind of like a training mode that's set up. You're gonna go to main and then online. So if you can see this online right here, you're gonna click online. This will actually bring the centrifuge on. You might see an error reading right here initially. It should go away. If not, it'll tell you what it is. So up here you have the set speed, your actual RPM down here. You have your start, stop, your tub temperature, your actual temperature. This down here, this box is all for logging. So this is gonna be, it logs to Excel. If you click on this little box here, this is where it actually logs to. So this will bring up your Windows file here. Right now it goes into test data. So it's on the C drive. Test data. If you go down here, it says custom. If you do all files, you'll see some log files here. So this is the template that we use. And then this is actually some data here. So this is what the data will actually look like in Excel if you go into the C drive. So if we go to C, let's see it here. Test data down here, double click it. This is gonna be our actual data here. So if I open this file, we should get some data. So you have tabs down here. You have cup 1, cup 2, cup 3, cup 4, 5, 6, etc. You'll only have 6 cups if you do the 1-inch samples. 1.5-inch samples have 3 cups. They'll still be here, but there won't be any data because you're not logging it. As you can see, there's just nothing here. But if you go back to cup 1, we do have some data here. There's not much, but it'll show your elapsed time in this column, column C. You have your RPM that we're reading, your rotor temperature, heavy interface and light interface, produced volume, capillary pressure, and displacement percentage there. If we go back, what you would want to do if you were creating a new file, what you could do is go into the C drive again, test data, take this template, you're going to copy it. So if we copy this, it'll say copy here. We rename this to whatever days, whatever you want the name of that is going to be. A lot of times we do the date or what kind of test it is. So if it's a drain run and today's date is January 13th. So if you do 13, 1, and then 2021. So that'll be that date right there. I don't know if you can see that, but so once we have that file created, we can actually go into the folder here. Instead of going to custom, go to all files, and then there is our newly created template there. And you just hit OK. Look down here, make sure it's actually updated here. When you do the automated test, so that's this block over here, when you hit start, now it's going to log to this area here. So you don't have to manually run any of the data, it automatically logs. And that's because of this automated test here. So the results box up here, this is going to be your heavy interface, your light interface, produced volume, capillary pressure, and displacement percentage of pore volume, PV right there. Strobe light adjustment, this is going to be your light intensity. So you have, right now it's 50% light intensity. It will change depending on the speed of the RPM normally, and this is all in the auto parameters for your actual run. Pulse width, so this is, it's number 70 degrees. You normally don't adjust this. Latency is time, so this is a time, this is all in the setup as well. You shouldn't have to adjust this, but this is the timing of this strobe, of when it strobes. And then cup 1, cup 2, this is what cup it's on. Again, in the automated test, it automatically will cycle cup 1, cup 2, cup 3. Your ROI start and end, this is going to be this scale, the X scale right here. So right now it's set the ROI as 1,000. So now we're looking for an image between 1,000 and 8,000 range. And then you have heavy interface and light interface, and that again is these two numbers up here. And that's going to be your red line and your blue line. And that's where the software is actually seeing the interface, and that's what it's saying. It'll give you numbers. So right now it says 533. Obviously there's nothing there, but we don't have anything, it's not running, but it will update to those actual numbers of where they're at. And then to your automated test here, you have your start. Obviously you can skip forward, so this will skip to the next step. You can do up to, I think, 15 steps. The log continuous time, it's in hours. This is, so 0.05 hours is like around 5 minutes or so. So this centrifuge is gonna log every cup. It'll do cup 1, cup 2, cup 3, over and over and over for this amount of time here. Once this time is up, then it's gonna log this time. So this right now is 0.5 minutes, so half a minute, which is 30 seconds. So now the centrifuge is going to log every 30 seconds after this initial time. So all your tabs right here, this is your main tab. Obviously it says main. You have online, select communication, offline, view communication error, and exit. Exit's just closing the software itself, but the communication errors, so this is where I said in the beginning you might have an error here. It would show up. You have a CDAC error, Beckman centrifuge error, frame grabber error, Watlow, and Gardasoft strobe controller. CDAC's the data acquisition for the software. That software is going to be right here, in NI Max. Beckman centrifuge, this is if you lose communication to the Beckman itself, like the Ethernet cable. Frame grabber is the board that actually strobes, so that'll be that. Watlow is the heater, so that'll be your heat up here if you lose communication with that. And then Gardasoft strobe controller is the actual pulsing of the light, and their software is here. And we can go into that later. And then logging again, so you have edit log header, so this will be the actual what it logs. So if you look in that test data sheet, it's going to show this data here. This is just a text, it doesn't have any calculations or anything like that. And then you have start and stop logging. You don't ever really use these because the software automatically logs when it's running a test. And then test criteria. So you have set alarm limits, which you won't change. Those are your alarm limits, it'll just go off. User parameters, you'll use this a lot before you set up a test. You have sample ID, so this is the name. Sample diameter, so obviously it's diameter in centimeters, length in centimeters. Sample material, this is also just for reference. This is going to be the type of material it is. Dry weight is important, so you want the dry rate of your samples, and then you also want the pore volume of your samples as well. And then this is your fluids down here in this box. So you have your heavy fluid and your light fluid, and that goes by density. So what you're displacing and what you're producing goes in here. And then you also need the densities there. The image, you'll never really change this. This is your heavy and light interface, and we'll go into that later. But that's a fall and a rise, so that's what the software is looking for. Your receiving tube, this is also just a name. This is just for reference. And then your R-tube ID, which this is crucial, you do need this number. So this is the ID, which there'll be drawings for this. And then your starting volume, so this is, if you start with 2 or 3 cc's or whatever you start with, you need a reference point. You'll put that number in here too. So you'll always start with some sort of start volume here. So the next one after edit user parameters is change COM port. So you'll also never really do this either. This is gonna be your Watlow controller. That's the only one on there, but you shouldn't have to change this. this is auto parameters, so this is your actual test parameters here. So this is what the test will actually run. Like I said, you have up to 15 steps. So this is RPM, light intensity. So this does change. A lot of times at low RPMs, it might only be like 20%. It is a percentage. And then a lot of times towards the top end, you will get up to a high, almost 100% light intensity. Pulse width probably won't change either. You'll keep this at normally like a 6 or a 7. And then you have equilibrium criteria for the actual test. So again, you click here depending on what cups you want to look at. Right now it's just 3 cups. But your delta volume is the amount of volume produced and the amount of time, so equilibrium time. So the software is going to look back at 0.05, which is, like I said, is about 5 minutes. So the software will look back at each cup in the last 5 minutes and has it produced less than 1 cc here. So if it's produced less than 1 cc, no change, it'll say that is good and it will go to the next step. So that would be step 1. It'll go to step 2 now, and it'll do this exact same criteria. But then you also have a minimum time here, which is 1 hour. You can set this to whatever you'd like. So no matter what, even if it meets this criteria sooner, it's still going to do at least an hour. So the next tab on test criteria would be the edit rotor parameters. So this is going to be the rotor itself. You can do up to 4 different rotors. This would be the serial number for the rotor, and then this is the model number. PIR20 is the 1 inch, PIR 16.5 is 1.5 inches. The 20 and the 16.5 references the speed. So the 20 is the 1 inch, it can do 20,000 RPMs, and the PIR 16.5 is the 1.5 inches, and it can do 16,500. And then there is the 30 millimeter here for 30 millimeter samples, and that has no reference to speed, just the size of the diameter. And if you actually look at the front of the centrifuge, the 30 and the 1 inch are in the same criteria as far as speed and temperature goes. The 30 millimeter, it can do 20,000 RPMs. Inverted buckets can do 16,000. That being said too, the max speed is always for drainage. The imbibition is always lower. And again, on the front of the centrifuge, you can see that chart that shows what the speed is and what the temperature is and what the max is for that. The delay offset time, so this is in degrees. You shouldn't ever have to change this. In the factory, we normally set this up. So this is timing of when the strobe triggers underneath the bucket. So you essentially have 360 degrees as a full circle. That's what this is. So you can do negative 360 or positive 360. We set this up, like I said, so you have to physically look down and time that light to trigger right underneath the bucket. And we kind of fine tune that. That being said, if you have a different rotor, that number might change and you'll have to manually set that up. And I'll do a whole video on just setting that up as well. Again, you can do up to 4 rotors. So this is rotor 4, rotor 3. You can see the green light. Obviously there's nothing there. So this would be rotor 2. This is the criteria for that rotor. So current rotor model, so just the model number, maximum rotor, sample diameter, max sample length, number of cups, RB drain. So this is the distance from the center of the rotor to the actual sample itself for the drainage, and that's in centimeters. And then obviously it's further away for imbibition. So imbib is imbibition. So now it's 16.63 centimeters from center. This current tube is probably the most important tab of all of the software. So if you don't choose the right test, your data would be completely wrong. So right now it's PIR, so that's the rotor PIR. 16.5 is the sample, so we're looking at 1.5 inches, and this would be a drainage test with 23 cc receiving tubes. And obviously you have all different kinds here as well. But this is the most important because that's going to correlate. So now if we close this, we've chosen that. If you go into calibration factor, that's going to show up right here. So now it's 16.5 drainage cc. This is going to be your data. We'll get more into this, but this is going to be how accurate your data actually is this chart here, making sure you do your calibration correctly. And again, we'll do a video just on calibrating the cups and the rotor itself. But again, that is your most crucial thing. So before you start any test, make sure that is all correct before you hit start. So after the rotor parameter, you have edit advanced parameters. So this is your advanced parameters. This is pixel range and intensity delta. So intensity delta is your y-axis here. So this is I should say this box is looking at this box down here in this graph. So you'll see when we actually turn on the centrifuge, but the pixel range is going to be the range on your x-axis, and your intensity delta is going to be the number delta this way on your y-axis. So what this is really saying is you're telling the software, I'm looking between 301 pixels at any given point on the x-axis. So you have 1,000, 2,000, 3,000. So any given spot, we're looking for a pixel range of at least in the 300 range, and we're looking for a drop of 900. So the drop would be, again, on this y-axis. Normally you're going to be looking at like 2,000. So ideally, in a good situation with a good image, you're going to have a drop of several thousand, right? It could be 5,000, and it should be within a very small range. That would be the best case scenario. But this would be a little more accurate, like I said, around 2,000. The problem is what you want to do is you want to pick up the actual interface and not just noise or light refraction or shadows. And again, you'll see it when we start the software, what you'll see there. So that's advanced parameters, and then you have edit calibration factor. Again, we just pulled this tab up. This is going to be just for calibrating your software, and we calibrate by a known volume. And we do that by 25%, 50%, and 75%. So again, you have, this is for drainage. You can see it up here, drainage, cup volume, offsets. This is for a drainage. The way you would change this is by going back into the rotor parameters. And then if this is an imbibition test, let's say it's the same test, but imbibition. So that would be a 23 cc imbibition with 1.5 inch. We click that, you hit save changes, you go to close, go to test configure, and go back to this calibration factor. And magically now we have a box here that's for imbibition. So imbibition is going to be essentially, we're looking at volume, a known volume as well, and it can be whatever volume you want it to be. Right now we did the calibration with 3 cc's, and this would be the light interface and heavy, or light and heavy. So we know that this pixel range, between this range, this is all in pixels here. So this pixel and this pixel, between that number, you subtract it, that amount of pixels is, we know for a fact that's 3 cc's, and that's how we actually calibrate for imbibition. With drainage, it's not. We're looking at volumes based off of 20, half, and 75 cc. So this would be our PIR 16.5 rotor. This is going to be an 1.5 inch rotor. Again, this is the disc underneath, so this is what we read. We actually read this little cutout right here. This cutout on the other side is for weight distribution, so this is just the equivalent weight on the opposite side to keep everything stable. So essentially, this will spin, and the sensor works, has a signal, so it's like a triangle. It'll send up, and then it'll read. So it'll send a laser, and it'll come down and read. When it sees the missing spot here, that's when it'll trigger and say that's 1 RPM. This is how Beckman reads. So again, I showed you earlier at the bottom there, they read this speed. This one isn't quite as accurate. We read actually every single revolution. Theirs, they kind of just round up or down. So again, the 16.5 rotor is 16,500 RPM max and can do 3 cups. You have 1, 2, and 3, obviously. If you notice, you might have these little cutouts in your rotor. This is for balancing, so they balance out. This is one chunk of aluminum, but you do have impurities in aluminum, and it might not be completely balanced, so that's how we balance it out. So there is 2 different types of tests for the centrifuge. No matter what rotor you're using, either it's the 1.5 inch, 1 inch, or the 30 millimeter, you're going to do an imbibition or a drainage, and this would be your drainage, and this would be imbibition. You can see this is, if this is the threads or where they stick in the body, the drainage, your rock would be here, and then for imbibition, your rock is here. So this would be producing fluid out of the rock, and then this would be forcing fluid into the rock. So normally you do a drainage test, and then you do an imbibition test. So that would be your reverse. This is what the actual cup looks like for the drainage. So it would look like this. You'd put this in there. See these little lines or these graduations? You don't want these visible in the centrifuge. This was the old way, and this is for manually measuring. If you were just looking at it, you would do that. But when you put this in, you don't want it showing up either the front or the back. So you're always going to turn it over, and it would look something like this. So now you would be seeing this. But I'm going to pull it out just so you can see it. So right now in this cup, this is water. So this would have been produced. This, we already ran a test. So this is produced water, and then this is the actual residual oil in there now. So ideally, you would start with a core sample that is completely saturated with brine or water, whatever your fluid is. This would be your heavier fluid. Obviously, your heavier fluid is going to go to the bottom. And then you would fill up the rest of this cup with your lighter phase, or sometimes people do an air test. This particular test was water and oil. So it's isopars, 0.75 density, and then obviously 1 for water. With brine, it's a little bit higher than that. You'll put that in the software as well. So what this test did is you would put your sample in here. You can actually see there's a little bit of oil left in there. The sample goes in there. When you spin this, it's going to be pushing out the water and then displacing the water with the oil. So in our test, we are going to be looking for the interface actually on this float. This float is right in between the oil and water. We're going to be looking at the bottom side of it. That's going to be our heavy reference. That's going to show actually how much produced brine came out of the sample. And then ideally, we would see the same amount produced brine is going to be replaced with oil. So now that amount of volume or cc's is in the actual sample. So that would be the first test, and we would graph that. Second test you would do is with imbibition. So again, this is your imbibition tube. This is what it looks like. There actually is a rock in there right now. This is a dyed oil, so we can actually see the oil, and we'd be measuring on either side of this oil, and then you're spinning it this way, so you're actually forcing your brine or your solution back into the rock and seeing how much goes back in, and then you're measuring the produced oil that's coming back out. This one is clear oil. That's a clear oil. We start our imbibition test with a little layer of really saturated dyed oil. So the centrifuge actually comes with an oil soluble dye that you would put in there, and then in the software, if this is 2 cc's of oil, we would put in there, we put in 2 cc's of oil. Obviously it's more than that now because this is produced oil from that sample. But now you're displacing oil with the brine. So you're gonna graph the two and see what kind of sample that is, at what capillary pressure it produced X amount of fluid, or how much it took to produce, or something like that. And this also has graduations, and you don't want those in there as well. So you would just take this and drop it in like this. I don't know if you can see, and this is our interface right here. So I've kind of brought you down to an eye level here of what you would see inside. This is, like I said, so this is after an imbibition run, and this is what you would see. Again, that's your dyed oil right here. So you have your dyed oil. This would be your water. So this is how much produced oil came from the sample, and you can even see with your eyes that like this sample over here obviously didn't produce nearly as much as this sample over here, and that's just that's based on the rock itself. If you're looking at this, so when we do our calibration, you can see this is the 23 cc imbibition tube. We stained this a little bit. If you let this sit a little bit, it would actually separate or better. Obviously that's what the centrifuge does, is separates the fluids, but you can see these graduation lines, and you can see on the actual tube here. So the little canister that this sits in, you're not using all this volume up here. Your visual window is only the size of this graduations. So we're pretty close to the top of where we can actually measure with the camera, because the camera can only measure in this window here. So you have to take that into consideration when you're adding your fluids and everything, that you always want to be inside these graduation lines. Anything above this, the camera will never see. So normally, like I said, this is what the end of a test would look like, but we would start with a little bit of oil layer, like a 1 or 2 cc. So if this is a 23 cc, we probably started with like maybe 5 cc's, but normally towards the top here. So this is the highest we would ever want to go, is 3/4 of the way up of this graduation. So right there is the top, and what's going to happen during the test is that all this would all be water this would all be water here, and all this water is getting pushed into the rock, and then it's displacing the oil that's already in there, and this oil is going to get pushed out of the rock, and it's going to combine with this oil. And so this interface that started here is going to go down and down and down, and it's building, right? So we're displacing that. So that's what the software is measuring. It's measuring this to here. So we're looking on either side of this oil and measuring how much oil has actually been produced. But again, like I said, the camera can only see inside this window here. So once you have to pick your receiving tube based on how much pore volume of the actual sample. if you're doing the 1-inch samples or even a 30 millimeter sample, and the entire pour volume for that sample is only 5 cc's total, you wouldn't use a 23 cc tube. You would use maybe a 6 cc. Even that is that's over 100% of what you're not going to produce 100%. You know what I'm saying? So you're only going to produce, you know, maybe 70 or 80% of the pour volume, best case scenario. So that determines what size receiving tube you choose. So the drainage tube, this is similar too. So this is, again, now this is all your water, and then this is oil sitting on top. This is the end of a test again. So now we're pretty close to the top here of what the actual camera can measure. So if you can look at this, but if we pull this out, again, this is also a 23 cc tube. The drainage is a little bit better because this level here where they meet is pretty close to the level here, unlike the drainage or imbibition, it's different. So you know when you look at these graduations where you're going to be, you're pretty close to the top, 3/4. Again, this is a perfect scenario. We did this, you know, perfect. Whereas when we finished, we're close to the top. You want to start, you know, you're going to start, if it's 23 cc, same thing, you'll probably start with 5 cc's here, and then you're going to add all oil. So this float would have been way down here at the bottom, 5 cc's, and then the rest of this would all been oil. And then again, the sample itself is about 10 cc's. So we produced the 10 plus the 5, that puts us right about 3/4 or so there. And that's exactly what happened in this case. But again, you have to be within this line here or the camera won't ever pick it up. The closer you get to either edge, so the bottom and the top, the camera has a harder time finding that interface. So you never really want to be at the very ends of this tube. Again, so you're going to choose your receiving tube based off a pour volume of the sample itself. So this is pretty much what a deconstructed tube would look like. Like I said, this is the original. So this is where the core actually sits in. It's cone down there at the bottom. You have an O-ring right here. Comes out down here. This is the lip where the receiving tube actually sit into. You can see there's a little lip there. So this is like the distribution plate or distribution plug kind of. So the rock will actually sit on top of this inside the sample like that. So all the fluid pushing out of it will hit that, and it will flow down into the cup and then into the actual tube itself. So you would take this, you have a little O-ring in here. So this O-ring inside here, you want to make sure that this is all cleaned or new. That's going to seal with the cap itself. So the cap will actually push down on the actual O-ring right there, and that'll make that seal. So you would take your distribution plug, you'd put it down there. You want to make sure that the grates are up again, so it's all fitting down. You take your sample, you put your sample inside like that. So it sits 2 inches the max, and then this is your receiving tube. Again, make sure this O-ring is clean, greased, new. You don't want too much grease on the O-ring because you don't want it when it starts spinning, it'll actually run down the sides and it might affect the image itself. So normally you take this off before you actually grease it. So you squeeze it like that, and then you can kind of pull it off. And same thing, so you grease it like this and then put it on. Once you have it on there, this is a little bit tricky to get this on, but the biggest thing is I lay this flat on the table and kind of do a little bit of a turning motion. So if you take it and you put it onto the table like this, and then you push down and twist a little bit. What's going to want to happen is it's going to want to squeeze this O-ring, and it'll squeeze out. If you keep pushing down, you can actually cut the O-ring and it can leak. But the biggest thing is you don't want to leak right there. So if you push it down and kind of turn a little bit, and then make sure it's not sticking out. This one's a little bit easier, but some of them, especially when they're new, they don't go down there very well. But like that. You would actually, this is your float. So your float would go in there. You would start with some amount of fluid, by the way, too. So like, again, the 5 cc, so you put 5 cc's of fluid at the bottom down there. And then you put your oil on top of that. Put that on. You would put oil in the bottom down there. So you squirt a little bit of oil with a syringe down in the bottom. Put this on, put the rock in. You would squirt oil in around that, and then you'd put your top on. You also have a little screw that goes into the top here, so this screw, and there's also a little O-ring on there as well. But you would leave this out, so you leave that screw out, put your cap on. A lot of times you have to use like a wrench just pretty much take it all the way down. You don't want to over tighten it, but you'll bring it all the way down. You're going to compress that O-ring inside there, and then you're going to put your screw in the top. You would also, with an oil and water drain, you would actually take a syringe and you would push more oil in and make sure you fill all this up. Also, where every single cup, so all these cups have to be within 0.2 grams of each other, and this is where you would add your weight. So we use like lead shavings or some type of lead weight or something, and you put that actually on top of the rock itself when it comes to drainage. So you put that there, and then again, put your screw on, snug it up. Once that's tight, you put it actually inside. Make sure, again, your graduations are not in the window. And then this will actually compress down a little bit. And you'll see that press into there. You take your rotor, put it in this cup one. Once you have, you're gonna screw this down all the way. So if this is your cup, you'll actually screw it till it bottoms out, and then you're gonna bring it back. This window is straight up and down. So you want this, you want your light's gonna be underneath here, and then your camera's gonna be above here. So you want this to be as straight as possible. So again, once we put the rotor in, you would have all three of your buckets in. But the biggest thing is, like I said, having that window straight up and down and having that light directly underneath the window. If you can adjust this light in or out, depending if it's imbibition or drainage. The biggest thing is having that at least the light is back far enough to cover at least the window, whether it's imbibition or drainage. So you want it just like that. And then when we close this window, the same thing. You want this window to be directly above the light, so it's all one line. And then you would take your camera, and the same thing. You're gonna put it on here, and you want it, again, you want your camera lined up directly. So if we zoom out a little bit, you can adjust this. It's an XYZ axis here, but you want your camera to be directly lined up. So again, everything needs to be lined up directly. Purely for demonstration reasons, I put an imbibition cup in there, and then I also put a drainage cup in there to show you where that light will actually be at. So if you look at right now, you might want to move that light in a little bit. So you'd move this up so it's completely underneath. It is, for the most part, it is underneath it, and it's actually good for the drainage too, so you might be okay. But you could move that light actually in a little bit. You don't want to move it too much, so I always give it like a little rock test, and you can hear and feel if that hits that light. If you rock it and it hits that light, you're too close. You can see it looks pretty close, but it's actually above it. What's going to end up hitting it is this disc. This disc is going to rub up against that light. So right now we have a little bit of room, not a lot, but you do have a little bit of room. As you can see too, like it will still trigger that light when it sees that reflector. So this is the PIR20. This is the 1-inch rotor, and it will be very similar to the 30mm rotor. It also has 6 spaces for samples. So it's much larger, but it's still the same concept. You still have an overspeed disc. This disc it looks the same, but it is a little bit different. Same here. This looks similar, but this one is the same. The cups will look a little bit different. So this is the imbibition version. The rock in this one will actually sit by itself. This is the whole thing, and then this is the receiving tube. The receiving tube actually has an O-ring on it, and that will seat down into the bottom down there. So this is literally the entire setup, so it'll be like that. Again, though, same thing. You don't want your graduations in the line of the window, but other than that, it's the same. So you would actually take your sample as is, and it would just drop down in there. Your sample's in there, and that would go in like that. The drainage is a little bit different. So this is kind of the housing for the drainage. This is what the actual sample is in. You have 2 O-rings here, similar to the 1.5 inches, but it's a little bit different. Again, this would be your sample. Your sample would go in like this. This is the receiving tube for the 1 inch. Right now there's a little bit of fluid in there, so that would be like our starting point. And again, that might be 1 or 2 cc's. And we would subtract that in the software. But so it goes like this. You want to make sure that has a good seal. All the O-rings are okay. There's a flow in there as well. So this will actually go inside of here like this. So this O-ring is going to seat right there. Again, we don't want these graduations in the window. So we're going to move it. You're going to push it in, and then you're going to push it down and seat that O-ring. These are the lead shavings I was talking about earlier, and this is how we get all the samples within the same weight. So you would do this towards the end, and you're gonna do this with every single sample that you have. Everything has to be within 0.2 grams of each other, and you'll use lead shavings to do that. But once you get your shavings on there, then you have the cap, and you'll screw the cap on as well. You also have a screw on the top here with an O-ring in this as well. So you'll bring that down. These ones are probably one of the more tough ones, and you probably will need to use like a soft jaw wrench. So this is the soft jaw wrench. This comes with all of the centrifuges as well. Sometimes you need to put this in a vise. This is aluminum though, so you don't want to squeeze this, so you'd put this in a soft jawed vise, maybe with a rag or something like that, so you don't scratch it up. Sometimes you can do it by hand. Just depends how clean your O-ring is, how well you've greased it. That way I actually just did it by hand. A lot of times if you heat this, or you run this for a long time, or it sits for a long time, it's quite difficult to get this off. And that's where I say sometimes you need to put this in a vise, but you don't want to damage it. Like I said, it is aluminum. So loading this in would be the exact same story. You would turn this in all the way. Wherever it bottoms out at, it's bottomed out. You're going to bring it back to where it's straight up and down. You would put that straight up and down. Again, you would never put these in together, but just for demonstrations, I'll show you. It's the same story. Bring it back a little bit. So if we're loading this, it's the same setup. Shouldn't be really much different. Again, though, you want to make sure now that light is directly underneath that bucket. Same with the imbibition. So once you switch to the 1 inch, like this rotor, or the 30 millimeter, you're looking at much smaller buckets. So normally you won't have an issue. Like right now, both of these look fine. You won't have any issues like that. But, and then again, you would line up your camera, put your camera on, and then you would use this X-axis over here in the back here to slide this back and forth. So you might want to slide this down. You'll know when you actually look at the software where to move that camera at. So once you get all your samples inside your actual little core holders here, you're gonna wanna make sure they're all the same weights. Like I said earlier, you need to be around 0.2. I always say, or close to identical as possible. So you can use anything to like hold these up. This is just a little beaker, just something so now you can actually weigh this. So now we can say that that weight is 208.75. You're gonna weigh every single one of them separately with the caps and everything. So, and then you're gonna take your heaviest one whenever you determine that one. So this one is our heaviest. And then we will tare this to 0. And then we'll weigh each one of these and make up the difference. So these have already been done. So it's very, very close. But we would take our little lead shavings here and then just make up that difference. Like that was too much, but if we took, see, and then once we get that to 0, now we're gonna take that lead piece, we would open up the cap here, and then we would put that little lead piece inside. So this is our 1 inch rotor. We have all of our, well, those are no samples in there, but these are just like known volumes in there, and there is a float in there. We'll just put this inside there, and then we'll just close the lid. You want to make sure it's not wobbling when you close it too, just kind of keep it. And then try not to slam this lid as well. And also try not to get any fingerprints on the actual lens. So you've got that closed. So after we've closed the lid, you're gonna put your set point in here. So you can put in whatever number you'd like. It goes again from, normally you're obviously gonna start out at a lower RPM. So around thousands where you can start. The lowest I think is 660 RPMs, but we'll just hit, and you'll essentially just hit start. And you'll hear the centrifuge kick on. And then you should see in the actual RPM it's going up, which is good. And might overshoot a little bit, and it should find itself. And you can look in here in the image area. So the image area down here, there's no image, it's black because we haven't actually put the camera on, but you are seeing some frequency here as well. So as you can see on the software here, centrifuge is running on Beckman software. This set temp will go to 25. We manually send the actual signal to the Beckman to cool to 25. So this should always be around 25. The temperature, if you are doing temperature, will actually be in the actual temp here. That's what you're looking for. So that's rotor temp, and this is tub temp. Tub temp, we always want at 25. And then you can see the vacuum is going down slowly here. Given enough time, you will get down to 1 or 2 microns. I've actually seen it get to 0 once. It's not that common. Normally around 2, 3, 4 microns is pretty normal. Eventually, given enough time, maybe 12 hours or something like that. As you can see, like I said, we don't have anything here. We're gonna take the camera. We'll set the camera. There's 2 little pinholes you'll find. And then we have an image here as well. You have all these axes, like I said, you have an X, Y, Z, so you can move the camera this way, up and down. Up and down is mainly for focusing and things like that. You also have an aperture right here, so this is the amount of light that is coming into the camera. And then you have an axis back here, and this, probably the most common one is gonna be the one in the back, and that's gonna actually move that camera side to side. So when you have different imbibition, drainage, and then you have 1 inch, 1.5 inches, and 30 millimeter, that's when you're gonna move it side to side. Okay, so it didn't show the vacuum on that last one side, there was a glare. It's 239 microns right now, which is actually a pretty decent vacuum, especially running at 1,000 RPMs in only 4 minutes. But it will, like I said, it'll go down over time. So the vacuum pump will actually heat up, and there's an intensifier in there. Once all the oil and stuff warms up, it'll actually go down much faster. Also, the speed of the centrifuge will increase that RPM, or the vacuum number. The vacuum number really doesn't matter to us as much. The Beckman has a bunch of fail-safes though. If it has a slow vacuum, or there's water in the oil and things like that, in the vacuum oil, it won't be as good, and you'll get errors. So if you do get an error, vacuum error, that's because your vacuum pump either has a leak, so one of the seals on the top, or the vacuum pump grease has moisture in it, and it does get moisture in it if one of the seals in the buckets leaks. So the vacuum will actually pull vacuum out of the buckets if those seals are not cleaned, or if there's a tear or something like that. You can also see that in the data. So now if you're looking at the data and all of a sudden you start losing production, you have a leak, and that leak a lot of times is getting pulled from the vacuum into the vacuum pump itself. So if you can kind of see, we have a very good image. So right now this is all water and this is air. This is just a reference. This is a reference volume. That's that float. You can see this red line is your heavy interface, and then the blue line is your light interface. And then both of those are being displayed, either heavy interface here and light interface here, and then also up in the results area. So you have heavy and light. So this is in pixels. That is where it's actually looking at. Again, we talked about ROI start and end. This is the area that we're looking at. So right now this cup is right around 1,000 to about 7,200, and you could adjust those parameters as well. So now we're saying this is what actually measures, the actual measuring of the system is between those heavy and light interfaces. So you're using the heavy interface for drainage, and then for imbibition you're using both. So in the imbibition you're looking for the heavy and light to separate because the oil is growing. In the drainage you're looking at this bottom end, and you're actually producing water, so that will go this way. So again, drainage, that heavy interface, the red one, will go to the right because you're producing water here. And then in imbibition, if you thought of this as oil, that will actually grow and they'll separate. And that's how we actually measure those two volumes. So that's why those numbers are so important. If I adjust, this is the aperture. If I adjust this to make it, bring in more light, we get these really nasty lines, and these are all shadows and things like that. But you can see now that we lost that light interface because that's not a very good image. It doesn't know where to look. And that actually comes from these advanced parameters here. So again, when I was saying earlier, advanced parameters, now we're looking for a 2,000 pixel drop. And apparently that's not 2,000. It looks close, but we're in that 300 range. If we were to change one of these, maybe if we change this to 1,000, it might pick that up, right? So it might pick it up now, and it did, see? It is picking it up. It's a really poor image, but we did get that to actual pick up because that must be 1,000 pixels, or minimum of 1,000. Obviously, you wouldn't want to run the centrifuge like this. You would want to fix your problems to why you were getting a bad image. You want a nice, crisp image. There's a lot of ways to get a good image. And one of them is aperture. One of them is bringing this up and down, which is essentially your focus. So if we were to move this up, it would make that much more thin because you're further away. The focus from there you probably can't see, but it's slightly blurry. And again, if we get too far away, it's completely gone. Same here. If we go too far to one side or the other, you might lose it. You might be okay. Yeah, so it's gone that way. We're back. And then also you have this access from side to side. You can see we're slowly moving. We've moved all the way to this side, but we're not seeing the whole cup. The idea is to see the whole cup. So if we go back, that would be the end of the cup and the top of the cup, or the top of the window. So what we're looking at, again, this would be the bottom end over here, and then this would be the top end. So as we adjust and go this way, now we're only seeing the top end. And you would do something like this. Normally you move inward to do imbibition, obviously, because imbibition's visual window is to the right and drainage's is to the left. But again, this is a drainage test, so we're going to bring this back this way. And again, normally you want to be about there. So once we have a good image now, so this is kind of a best case scenario, like I said. So this is your water, this is your air, and this is a plastic float in the middle. You can see these very large contrasts from white to dark. This is, like I said, so it's best case scenario. Sometimes if you use oil, you're going to get a lot more refraction from light and things like that, but for training purposes, we're going to use water and air. If you look at the light intensity too, we're at 30%, which is kind of low, but we're also at a pretty low RPM. You could probably bump this down to even 10%. So if you hit 10 and then you hit save changes, it'll actually update, and you can see now how this got a little thicker, but it also isn't very crisp. So you're kind of fighting with that too. You can now, if you really wanted to, you can maybe adjust the zoom on the actual camera. You could make it so it could be a little bit more crisp. But ideally, you're probably just going to do a little bit higher of a percentage and find the correct one. So I just bumped it to 20, and that's much, much better. The reason you're going to do this, so now this number though, so if you were doing an actual test, you're going to go into your auto parameters, auto parameters here. So this first step, they've got 1,225. If it was 1,000 RPMs here, our light intensity, we just checked it, it's going to be 20. We would put 20% now, because we know for the setup that we have, 20%'s good enough. 50 might be too much. So again, we would save that. And then if we want to go up and check, we would check one of these at a time, but we'll go to 2,000. So if I put in 2,000, I put it in, you can see that it hasn't actually jumped up yet. If I click off over here on the software, it'll send that command to go to 2,000. So now it's going to jump up. You'll lose your image in between the RPMs because now the software is looking at 2,000 RPMs. When it hits 2,000, our image should come back. Yep, and there it is. Overshot, undershot, it'll find itself. And so the faster that it finds itself, or finds that RPM, that's based off of the balance of the rotor itself. So now we're at 2,000 again. We're at 20%. You might go up to 25. You can try 25%. If I click off, it should update. So 25 actually looks pretty good. Now if we get back into our auto parameters, step 2, 2,000 RPMs and 25%. So now we know that that step is 25. And then obviously you're just going to keep going up. If you get up to, let's just jump up to like 6,000, we'll jump up 3 times. So if I put in 6,000, click off the software, it should go to 6,000. in any normal test, you would never do this. You would never jump up by thousands like this. This is just for the sake of showing you now what the image will be like. We still have that 25% value in the light intensity, and you'll see that, oh, now look at, we have a much larger, it looks to, or appears to be a much larger float. It's obviously the same size float. It hasn't changed based off of RPM. That's literally just the light and the shadows and refraction and things like that. So we're getting all this haze right here. That being said, if we jumped up 3 times, it might jump up the percentage 3 times, it might not. So we can try, we'll just jump to 50%. So this would be 50% light intensity, see what it does. Much better, still a little dirty, still a little hazy there. It would work, it's pretty good, but maybe even 75% would be ideal. And again, right, 75% is much better, so that's pretty much how it works. It normally steps up in percentages, just like RPMs. Obviously you're gonna end up getting to 100%, and that might be at, your higher RPMs and things like that. So when we talk about calibration, calibration is the most important thing for getting accurate data for the centrifuge. So if we say this is a drainage test right now, so we want to calibrate for drainage, we're going to go into test configure, and then we're going to go into rotor parameters first. That's the first thing you're going to do. And the 2 reasons you're going to do this is because you're looking for, make sure you're on the right rotor and make sure you're on the right tube. So we are looking at 16, this is the serial number for this rotor, and this is number 20. So that's all correct. And then you're going to look for the actual test that you're going to do. And this is PIR 20 drainage 4cc. So this is a 4cc receiving tube here. So we'll click OK, we'll hit save changes, and then we hit close. Now when we hit test configure and go into edit the calibration factor, it should be there now. So we have 0 data here to start off with. What we have in there right now is probably 2 cc's. So 2 cc's is right in the middle. This would be our 50% calibration. So the whole idea of this is to calibrate that volume at that speed. So this you're gonna have for how many steps? This is gonna be for your actual test. Right now there's only 4 in there. Let's say we wanna do 10 steps, right? And 10 steps essentially means 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7, 8, 9, 10. So once we're in this field, like I said, you have your 10 steps here. You are going to put in, this is all in pixels, right? So if we look at, you're gonna do the heavy interface too. So we're looking at this heavy interface, so it's this number up here. So right now it says, it's kind of bouncing between 38, 32-ish. That's the number, so it's 3,380. So if we put in now that 50% is 3832, we're gonna hit save changes and we'll hit close. Put 2 cc's in this too, we know that. And then the software is saying that this is where that's at. We update this, and then in produced volume, you should get around 2 cc's. That's kind of the idea for calibrating. So you're taking a known volume that we weighed out on the scale. You want to make sure that's accurate as well. And you're essentially saying that that is 2 cc's, and it is. So it's half, right? We know that we put in the 2, so there's 4 total. That's the 2. We'll go to our next step, 2,000 RPM. So we'll wait for this to stabilize for a sec. Again, so we've hit 2,000 though, but our light intensity doesn't change automatically when we're running it manually. So that being said too, we want to change your light intensity as well. So we know that our test for 2,000 is going to be 25%. So if you can see here, produced volume is infinity. That's because if you go back into the calibration, there's no data there, it's 0. So you're just going to get an infinity number. Now we have to adjust this. It's not going to be the same. Normally it's going to go down. So now if we look, it's 38. It bounces around a little bit, but we'll do 30. 822. So we'll hit save changes, and our produced volume is right around 2 cc's again. If it's not 2 cc's and you know that there's 2 cc's there, then you need to adjust that number. So you have to go back in and edit this calibration factor, and you can just adjust this slightly. That being said, the longer you sit at 2000 RPM when you're doing your calibration, it will stabilize slightly over time. So a lot of times what I like to do is to actually run an automated test as my calibration, and then I actually average out the heavy interface for each step. So in the Excel sheet, I'm just literally, like I said, so if it's 1 to 2000 and it runs for an hour at 1 to 2000, I'm gonna average out that heavy interface the entire hour. And then I'll put that number into the calibration factor here. So, okay, so the next step is 3000 RPM. Again, we're a little blurry. We are going to adjust our light intensity to 30%. We'll see what it looks like. Still a little blurry. I'm thinking 35. Oops. Do 35%. And it's pretty good at 35. Again, you would go into these auto parameters here now, and our third step here would be 3000, and we would do 35. And you want to make sure, again, when you have to set all these numbers. If you forget, it's just going to do whatever is auto or last put in there. So you could get all these random. That will make your calibration way off. So hit save, close. And again, we're getting to infinity because we don't have a value in. So now if you open your calibration factor, you're going to go in. I like to move it just below it. I'm only looking at the heavy interface here, 3000 RPMs, 50%. It's 38, kind of 38.15 or so. So as you can see the trend line, we're slowly going down. Like I said, normally, and the reason this is like I said, it's in pixels. So now that 3800 or so is this number down here on this X. So what's happening is that this bucket actually under the capillary pressure is actually, it's actually moving out. So it's stretching is what's happening. And this is why we do calibration with actual fluids and at actual speeds. It's just a little bit more accurate. All that being said, that calibration is so important, I'm sure the question you're asking is, so what if I change anything? What if I switch to imbibition? What if I switch to 1.5 inches instead of 1 inch? What if I adjust any of my settings on my camera here? So what if I move this up or down? What if I move it side to side? Will that change the calibration? Absolutely will change the calibration. That being said, after it changes it, it's very, very easy to get back to wherever you were. So if I change this out and then I put in the 1.5 inches, guess what? All my data in my test configure here. So if we go back into our rotor, right? If we go to our rotor parameters, and then we switch to back to the, we were doing the 23 cc drainage. Where's it at here? Now if we save this and go back, all that data is there from the original one. Obviously you changed things though on the lens. You've changed things on the camera. So now if we're here and we want to go back to the other one, so if we go back to the rotor and we go back to our drainage for the inch sample, where's that here? So drainage, we save changes. So this is the stuff we just got done editing. So if you look, again, all our data is still there. Let's say, like I said, so now if you look at the actual, we're still at 2, but let's say if we move this camera over, right? Because we moved it. Look at our produced volume now, it's 3.76 up there. Obviously that's not correct. We've adjusted things, we've moved things because we've done a different test. It's very, very simple to just move all your criteria back. So now look at, we're at 1.75, 1.79. We're slowly adjusting this. We know exactly how much is in that tube right now. So if you know how much is in your tube before you run it, before you actually run a test, you can put everything back to the way it was just from knowing what it was that you put in there. So ideally, if we were to run another one of these tests, we would just do a real quick sample run and we would get everything back to the way it was. So there you go. We've moved it back. We're right back to that 2 cc's. Same thing if we were to move this up and down. So once you have calibration numbers for drainage, for imbibition, for 1.5 inch, for 1 inch, for 30 millimeter, once you have all that data already in there and it's all populated, you just need to run a reference volume in that before you start the test, in which you're going to do anyway. So you have to run a reference run for drainage, and then for imbibition, you're going to do the same thing. You're going to put in like a known volume and just make sure everything's correct. So a little bit more about the calibration factor table here. You see you have cup volume offset on top, and you have 6 cups here, and then you also have a start pixel and an end pixel. So this is where we're saying where the bucket is starting at and where the bucket is ending at in pixels. So if we're trying to figure these numbers out, one of the easiest things to do is to actually use the software to find that. So obviously this is the start of the bucket over here. So you have start and you have end over here. So what determines where the software looks for those, you know, those contrasts essentially, or where that interface is. So this is our interface. It's the ROI start, the ROI end, and then again back to these advanced parameters here. The reason why, though, it's not choosing, this is obviously the end of the bucket looks pretty good, right? That's because of this 8,000 right here. So we've kind of cut it off, essentially. We're actually looking for a rise and a fall here. Earlier, I was talking about the user parameters here, and I was saying that interface, right? So we're looking for, you can't really see it there, but okay, so the image up here, this box, you have interface style, you have a fall, and a light interface style is a rise. So the fall is looking for a drop in contrast. So if I move this out of the way, as you can see, you're going from white up here, this is white, and then it drops dark. This line, that's a fall, right? So it's falling down, and then it's rising up. So it's going from a very, very white to black, and that's that interface. So if you were to look at, you know, an interface over here, it's going from black to white, and then same thing, you're going from white to black here. But that's what those numbers are right there. Almost always, it'll be a fall and a rise. There's very, very few instances where it's not a fall and a rise. The only other time is if you're using 2 types of floats, if you're using an oil float and a water float, which is not very common. But if we were to switch these two, it would actually flip the interface itself. So now that your heavy would be on one side and your light would be on the other. Okay, so that's the heavy and light interface style. If we change, so if we get rid of this 2500 for the start, and let's say we'll start it at 5,000, right? So if I say it's at 5,000, we've taken this interface right out of the story, right? So now it's not even looking at that, it's starting at 5,000. So right here. Now if you look at the heavy interface, it actually says 75, 17 or so. Now we know the software is telling you what that actually is. So now we can put in here, we just did a generic number, it says 8,000. But if you really want to be specific, you can do that number now. So it's 7515, we'll say. This won't normally affect much at all. Same with the start pixels. Same story, it won't really affect a whole lot. Normally you're not measuring in those very far ends. Normally you're measuring between this 25% and 75%. You don't really want to be too close to the edges, like I said. But we'll hit save changes and close. And then we'll change this as well too. So let's change this to like 900 now. So now we are assuming that the start is that number as well. So the blue one is light interface, so it's really around 1100 or so is really what it is. 1111. So now we'll go into here. It's not 20. We'll put that number in, save changes. And then, so if you're doing your actual test, you definitely want to make sure you want to remember, we do not want to pick up these ends. So you actually want to bring it past that. So if it's really at that 1100, we want to go to probably at least 1500 to get rid of it, just to be sure. So if I hit 1500, We should be taking this out, yeah. So we took this out of, and then same thing, really, 8,000 is a little high, 7,000 is probably more what you want to be. Just in case you do get, you know, if you do produce too much volume and you start getting closer to this edge, if this float gets really close to this edge or really close to the bottom, the software has a very tough time distinguishing between what is what. That's what ends up happening. It's doable, it's just very difficult to adjust those ROIs because you're talking about numbers in the thousands, and you know, you have to adjust them. You know, it might be 1,112, you know. So that's the start and end pixels. That's how you adjust those for each cup. When it comes to the cup volume offset now, like I said, you have one for each cup here. If you close this and we cycle through each cup, you know, we should be around 2, right? So we're at 2. It's not gonna be exact same for every single cup. So now cup 2, it's slightly different. It says it's 2.13 cc's, which we know there's 2 in every single cup. So, and even more so, cup 3 is even further off. There might actually be 1.75. It's been a while since I ran these, so you could have lost some fluid in there. But let's just say we know that there's 2 in there, so it's off by 20, you know, 0.25 cc's, which is, you know, obviously it's quite a bit of fluid. And it really could be that far out, but for the sake of this test, you know, we'll just show you. So if you're looking at these, you know, they're all off slightly. They should be pretty close. They're only gonna be a few, you know, decimal points off normally. So if we go into this calibration factor and we look at this volume offset, this is where you're gonna adjust that number. So if you look at cup 2, we're on cup 2, you're over by 0.13. So if we actually go into the calibration factor here now, and we adjust this now, cup 1 will always be 0 because that's the one we're actually using to do most of the calibration, but we can see cup 2 is actually 0.13 off. So if we put in that 0.13, it should offset it now. So if we hit save changes, we close this, and we're on cup 2, it will actually say now 2 cc's because we know that there's 2 cc's inside this cup. And then same thing, we're going to switch to cup 3. Cup 3 is actually 0.76 off, so it's quite a bit off. So when you're going up, like I said, we were down 0.25, you need to add a negative. So it's negative 0.25. And again, now we're back at 2. That being said too, so like you can see cup 6 over here is 2.12, so we're off by 0.12. If I go in and adjust this calibration factor and I say we put in 0.12, so I put in 0.12 and I hit save changes, cup 6 is still 0.12 because it's on cup 3. It has to be on cup 6 for it to measure cup 6. So as soon as I switch to cup 6, now it's actually measuring. It's only measuring that cup when it's on that cup. So when you do the automated software, it will actually cycle through the cups and it'll measure 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So with the 23 cc receiving tube, for 25% of this tube, it'll be 5.75 cc's. So if you take your tube and then you can put your float in or you can leave it out. Either way, if you zero out your scale and then you're going to add with a syringe your heavy fluid, this will normally be your brine, but you'll add 5.75 cc's. And that'll be our 25%. And then we'll put that in for our calibration, like I said, for our 25%, and make sure all of them will be the same weight and everything like that. But making sure they're the same volume, that 5.75 is the most important thing. So now that we have our 5.75 cc's or 25% in each one of our tubes, we're going to put our rotors together with the caps. You want to keep the same cap with everything the same, just because you could have some variances in the weight of the materials. Some things are more pure than others, so I try to keep them. On ours, I don't know if you can see, but we label it 3E, and then this one will say 2E, if you can see that. And then same thing on the top. You don't have to, you can label them whatever you would like, but we label them just to make sure. And then we'll put the tops on just slightly. And then we're gonna weigh all these to make sure they're the same weight, like I said, because you could have some variances just in the material themselves. So we'll zero our scale out, measure our first one. See, that one's quite a bit larger. Remember, so that is our largest. We're gonna tear it there. We know our second one is good to go. You can close the top. And then we'll bring our other ones up to weight. We will take our lead shavings and add that weight to it. This isn't very much weight, but it is a little bit. Take one of our smaller lead pieces there. It's pretty close, but so ideally we'll be at 0. And then we'll take that, we'll open this cap up. And for this test, you know, on a real test, you'd have your sample right there. This test will just set the actual lead inside there. And then close that one up. And then we have to do it for cup 1 as well. So we're off quite a bit on cup 1. And then 0.01, that's pretty close, so, well, 0.02. Could, like I said, tear this a little bit. There we go. Now we'll take our actual buckets here. So we have obviously 1, like I said, here's 2, and then we have 3 down here in the corner. You have, like I said, you have this O-ring right here. This is kind of like a guide ring. This keeps this straight inside the bucket here. It keeps it from moving side to side, essentially. It's not that important. It doesn't actually see any pressure or anything like that, but that'll seat inside here. Like I said, that kind of keeps it straight inside. And then again, look at your markings, and then keep them outside of the window. You don't want them in the way. So, and then it'll go in, and then we'll actually close it there. And then don't forget to tighten up your O-ring here. This is normally a Phillips. Sometimes it's a hex screw. But just snug that up. You don't want it too tight, just snug. You don't want it, that O-ring squeezes out pretty easy, so. And then obviously you'll put that in your slot 1. Once you put it in, like I said, you'll turn it all the way down, and then you'll come back a little bit. So it's bottomed out, you'll come back, and you'll have it straight up and down. And then you'll do that for all the rest of them. And then we'll drop that into the rotor, and then we'll give it a little spin. Make sure it's not touching anything like that. Give it a little bounce rock test, and it should be good. Again, you can double check to make sure the light is completely underneath your bucket. When you go close the lid, make sure this is stop rocking. You don't really want it shaking, just because then when you start the centrifuge, it could continually shake. It will eventually stabilize, but it could cause an imbalance on the Beckman itself. So it's not moving. We're going to close this. Don't slam it because we don't want it to shake the rotor as well. Just enough, and then that's it. So the first thing you're going to do is double click on the Smart Centrifuge software. Then our software will pull up. Again, you're going to go to main online here. That actually brings everything online. You'll see everything come back. And then we are going to, if there's no errors, you're good to go. You can just hit start at 1,000 RPMs. And then once we get it going, we are going to put on our camera here. get that into place. Make sure it's locked in. And this is what the actual bucket would look like at 1,000 RPMs right now. So this right here is our 5.75 cc's of water. This is our float here, and then this is all air. Right now the software says it's right around almost 6 cc's, so we know we're off a little bit. Also, if you look at our light intensity, it's still 50. And then if you look at your actual parameters here for the auto parameters, our first run at 1,000 is only 20. So let's see what it is at 20. Because this will be the actual test itself. So 5.9-ish, 5.92. So we would adjust now. We can either adjust the camera and move it over a little bit, or we can put in a new number. If we were doing a new calibration, we could just adjust our calibration factor here. So we would just say now this is, the heavy interface is 2057, seeing it's 2009. We can do that, or we can adjust the actual camera itself, the access point. So right about, well, it's kind of close right there. So there you can see our produced volume is pretty close to 5.75, which is what we would want. And again, I didn't have to change any of the calibration, I just adjusted the camera to bring it into that value. And then again, you'd want to do it for cup 2. See what cup 2 is, your 5.63, so you're off slightly. And then let's see what cup 3 is here. Cup 3 is also off slightly too, but that could be in our calibration factor here. That offset here, we can always adjust this offset, so -12 there. We should bring that pretty close. And then same thing, cup 3 would be the same. And then that brings us also on cup 3 to pretty close, like I said. And then you'd want to adjust this at your next RPM as well. So you'd go up to 2,000. And then we would check to see what that produced volume is at 2,000 as well. And once we're at 2,000, we'll go look at our auto parameters, see what our light intensity is. So we're at 25. We want to make sure we're at the same number here. 25. And we are on cup 3, so you're off slightly. Cup 2. Cup 1, you're off. So ideally you'd probably just come into your user parameters and then you adjust it for this one. So 14, let's say. And then again, we're pretty close to back to where we were again. And then we would jump up again to 3,000. Let's see what our user parameters are. 35. So cup 3, 5.58, we're off again. We're probably off on all of them, most likely, yep. So now we will go back into calibration and adjust our 3,000 number, so. We'll probably have to adjust all of them. So now cup 1, cup 2 and cup 3. And then again, you would just do this for every single step, adjusting your light intensity for the actual test criteria and adjusting the heavy interface and making sure they all read around 5.75 or 25% for every single step. Once we have our 25% volume, so our 5.75 cc's for all 3 of our cups, and then we do get that offset value for cup 2 and cup 3, we're gonna actually put the 25% in cup 1 again, so that'll be the same. We're gonna do 50% in cup 2, and then we're gonna do the 75% in cup 3, and then we can do the entire calibration in one go. Now, what I do though, I do empty them all and start over, just in case you have a slight leak and then that value, maybe it's not 5.75 on this one, maybe it's 5.7 or 5.69. And then I also don't just add to this, I don't add another to make this the 50% of the 23 cc's. I don't just add another 5.75. I do empty it completely and then I start over. And then obviously the same for cup 3 too. I empty it and I start completely fresh just to make sure all my numbers are correct. And then obviously we can't have, so cup 3 is gonna be 17.25 cc's, that's our 75%. We can't have that being that much greater than cup 1. We're gonna use our lead weights to make them all equal again. And obviously cup 3 will be the heaviest because it has the most amount of reference volume, like I said, at 17.25 cc's to give us our 75% total of the receiving tube itself. So again, here we have our cup 1, which is 5.75, and then our 2, which is 11.5, and then our 3, which is 17.25 cc's. And we are going to now match the weights in all 3. So obviously, like I said, our cup 3 is gonna be the heaviest, so we'll take our cup 3, we'll zero this out, and we'll go from there. So we'll take our cup 2, so now that we have our 3 different volumes in 3 different cups, again, why we put our 25% in cup 1, which is what we're on right now, we're just double checking to make sure our volume is correct. If not, you can adjust your camera, or again, you can adjust that that number in your actual calibration here for the 25% here. Again, we're at the 209 here, or 2009. This is the one we're going to adjust the 50 and the 75 this time, and then hopefully, like I said, our cup offsets are correct as well. So again, we are pretty close to that 5.75. If you go to cup 2, this is our 50%, which should be 11.5, and we're getting 11.4, so we're off by point. Well, it bounced a little bit, so we'll probably adjust that number. And then cup 3 is supposed to be 17.25, and we're over on that one, so we'll adjust that one as well. Again, when you're doing this, make sure Your light intensity is set at the same as what your auto test will actually be in auto parameters here. So again, make sure this is the number, because when you actually go to run your automated test, the software will automatically put that 20, 25, 30 when you switch. So again, what we would do is we would just go into test configure, go to your calibration. We're looking at heavy interface, so we're gonna keep that one. This one will be now the 36.99 there. And then 75% will be our other one, which is 55. We'll do 5560 and see what that gets us. You can always tweak these numbers too later just to see. So if we hit save, close, see what that number is. Still not seven. Like I said, we're looking for 17.25, so that's still not probably a great number. Somewhere around there, like I said. Well, let's go to cup 2. So now that we have all of our numbers here, if you look in our test, it's going to be 7 steps and up to 7,000 RPMs is what we have in. Again, here's your light intensity numbers. So we are at our 7,000 RPM. This is cup 1. We're right around that 5.75. Cup 2 is right around the 11.5, and then cup 3 is right around the 17.25 range. And we're at our 75%. So again, these are all of our numbers we just edited in the calibration. So I adjusted all of these to be correct and get the right volumes. So this is what it would look like if we just hit our automated test. You just hit start here. First thing that's going to pop up is your test file that you have in here, whatever you have set in here. Right now I just have test, literally just says test. And you can go in there and look. I already had this file open, so it's gonna, like I said, it's gonna switch between each cup. Cup 3. Right now, it's just we only have 3 cups in, so it's just gonna go 1, 2, 3. So now we're on cup 1. Obviously, this is cup 2 and cup 3. So you can look at the produced volume here, and it should be pretty close to what our numbers are here. Might be a little unstable, so like I said, produced volume. But what I was going to show you is the view plots here. So if you view plot, this is just for your reference. You can actually edit this field here, your y-axis here. So if you just click on this, double click, you can change this to 10. So now it's going to look from 0 to 10 cc's. Obviously, this is a 23 cc tube, so the max we could do is 23. If you put 23 in, it'll change up to 23. And then this will default to like -5. We always change it to 0. And then on this axis, this is your RPM. You can see RPM in white. Also up here, you have your cups. We are not going to log 4, 5, and 6 because we don't have them. And then you can right click on here and you can clear your chart. So we cleared it. And it will just start logging and it'll show you. Also, you can change this from 1 hour to like 10 minutes. We'll see, 10 minutes. And give it a second and it will start populating here. Yeah, as you can start to see it coming in right now. You can also go down to 2 minutes, much quicker. So now we're looking back at 2 minutes. Right now, these numbers won't change, obviously, because we're not producing anything. This is just our calibration volumes, so. But when you run your data, or when you run your real test, you'll see this, it'll kind of arc and then level off. Again, this is what it would look like if you were running a real test. It's just going to cycle through each cup and measure the produced volume. And if you wanted to, let's say, we're at our first step at 1,000 RPM. So if you look at our auto parameters, 1,000 light intensity. We're waiting again for this criteria to move on. If you don't want to wait, you can always just hit skip forward and it will skip to your next step, which is 2,000 RPMs for us. Sometimes when you switch between, you'll get some dead points or bad values here, and you'll should maybe see one. We'll see what happens here. The software will start looking before it's actually reached that RPM. See if it, yeah, see. Now it shows the red line, cup 2 and cup 1, it missed, and it caught it on cup 3. But this would be a bad data point, and you can actually see it in, you see the zeros here. So if we go back to cup 1, we'll see, yeah. So it missed it there, you would delete this point, and then delete this point in cup 2 as well. And then it goes back. And then same thing, you can just skip forward and keep going. And if we're done with the test, if you hit stop, it will close the Excel sheet. It will keep running just in case you wanted to continue on. Let's say, you know, we stopped at 7,000. If you wanted to do 8, 9, 10, you could just add them on and start the test, or you know, you would change it here. But you actually have to physically hit stop. This will keep going no matter what. You can just hit close. So deciding what receiving tube to use is based off of the pore volume of the actual rock that you're using. So this is the 23 cc. So this is the largest for the 1.5 inch samples. So 23 cc's total volume. That being said, you're going to start with some volume, and then you don't want to be maxed out at the top volume either. So the rocks that I have are around 11 or 12 cc's total. That being said, that's only, you know, half of what this tube is. That being said, we'll probably start with 5 or 6 cc's, and then we also want to be a few cc's from the top again. So right in the mid range. So you can push those limits. Like I said, you can start with only 1 or 2 cc's as your reference volume, your starting volume. Like I said, you don't want to ever start with 0, just because it's hard to distinguish the float from the bottom of the receiving tube itself. So the computer can't really distinguish the difference between here and here. So we always want to put a few cc's in that, you know, maybe 10% of that tube. So the 10% at the top and the bottom is what you lose. So you're only working with about 80% of that volume. Again, like I said, at the top. So once you start getting to the top with this, it has a tough time distinguishing what's float and what's the end of the cup itself. So anyways, for this test, like I said, we have a pore volume of 11.41 or so, and we're going to use the 23 cc tube. Again, you always want to start with some known start volume. We have a lot of room with this sample, so we're going to do 5 cc's of starting volume. We'll weigh that out so we know exactly what it is. And then we're going to put that number into the software later on, and that will subtract that volume from produced volume to be a little more accurate. And I'll show you that in a minute. You don't necessarily have to be exact with this, but it will help with weight distribution later on as well. Whatever this number is, like say if it's, you can put this into the software as your starting volume. But like I said, it's nice to be consistent. And then also you're going to have equal weights. So you might as well just put in equal volumes as well. You have a starting volume for each cup, so. So after we have our 5 cc's of water over here, if you were just doing a water brine test, you'd be all set to go to start your test. But this test, we're going to do oil displacing brine. So we're going to fill up our receiving tubes with oil all the way to the top. So this is our oil. Like I said, it's just a regular mineral oil that we're going to use for our test. It is clear. Again, we're just going to pour it in manually right now, and then we'll use a syringe later, but we're going to fill these tubes up all the way. You don't want to overflow it, but you do want to get it to the top. We ideally don't want any air inside the receiving tube at all. And then we'll put our tops on. Then we're going to take a syringe, take another syringe, different syringe obviously, and we're going to fill up that oil. We'll put a little bit at the bottom there. So if you can see, we're at the top now. We're going to fill up this. We're going to actually stick it down in there so we know we get all the oil down in there. I have a 5cc syringe here, so I already put about 5 cc's. We're still not, we want to bring up the level till it's kind of covered up this distribution plug at the bottom, and then our rock's going to go on top of there. You could just pour it in with the beaker, but you might not get it to go down this hole very well. As you can see, the air bubbles coming up. Obviously, that's what we want. You know, you're going to displace all that air down there. Put a little more in here just to see what we have. Still see some air coming up. Again, we don't want any air inside the cup. Looks like we're full now. Could be full on this one too, probably. This one appears to be full as well. So I've already prepped our samples here. This is going to be your heavy, so your first test is going to be your drainage test, and that's going to be your heavy fluid. Oops, poured a little bit on there. So this will normally be your brine or your water, like I said, your heavier fluid. You want a dry weight with these, and then you'll have a saturated weight, and then you'll have a pour volume. And ideally, you would take that pour volume from like a porosity meter or something like that. But so now we're going to take our samples, got them labeled. We've got some data on them already. You're going to dry them off on a paper towel, ideally unbleached, like that. And then we're going to weigh them again. And then we're going to write down our weight there. And then we would take our sample and we would put it down in the rock. And then again, we are going to try to fill up as much of this space as possible around the rock. Depending on the OD of your rock, it might be a little bit easier. You can't inject too fast either. You'll overflow it, but it's kind of a slow process here. Again, we want the oil to be displacing the water that's actually in the rock right now. We don't want air to be displacing the water. So we're you can kind of see it's completely up and around the rock on each side. We have this little screw hole in the top too. This is where we're going to inject we'll inject more when we put this on. We're going to weigh these first, but we'll put this on and we'll inject more fluid through the top. That being said, we still need to weigh everything. Now that we have all 3 samples with oil around them, we're going to weigh them all again. And then once we get them all the same weight, we're going to take this top one off and we're going to try to inject about the same amount of fluid inside the top through all three of them. And then we'll reweigh them and then inject the oil again to try to make them about the same weights. So after we've weighed all these out, we're going to take our 5cc syringe and then hopefully inject right around 5 cc's for all three of these, just to fill up that space in the cap. We're going to weigh all these again now that we have filled up with oil. That's pretty close, 0.03. And this one's pretty close. What you can do, take your syringe and just pull a little bit of that volume out. We'll weigh this again. Actually, we're a little under now. And then we're going to put all our lids on here. And then to make sure, after you've got this all put together, make sure you wipe this down. If you have any residual oil or any oil that comes out here or comes out the cap, you don't want, when you start to spin this in the centrifuge, you don't want all that oil to slide down and get in front of this area here in front of the camera. So again, we'll take our cups, make sure our graduations are not in the visual window. Push that down. Same thing. Make sure we find one. We put one in. Make sure it's upright. And then your rotor is ready to go into the centrifuge and ready for your test. So once you have the rotor in and the lid closed, make sure you put your camera on. I don't know how many times people will forget to put the camera on and actually start the test. So make sure you put your camera on. So once we have the rotor and the camera set up, the first thing you're going to do is go into user parameters here and make sure you have all your data properly put in. So diameter, length, the material name doesn't necessarily matter. You need your dry weight and then you need your pour volumes here. And then you have your heavy fluids. So this is going to be what's saturated with, and then the density of that. And then your oil that's displacing. And this is the density of our displaced fluid here. And then rise and fall, you'll keep the same for drainage. And then you have our tube ID, and then you have your starting volume. This is also very critical. We put in 5 cc's, so that will subtract from what's going to be produced. And then make sure you hit save changes, close, go into your auto parameters, make sure these steps are all correct, nothing's been changed. Make sure you want to run for this amount of time. You have a minimum time here of at least 1 hour per step again. and then double check and make sure your file is the correct file you have chosen. So I created one. Here it is, drain. It's a water, oil, drain, and then today's date. So this is the test file we're going to use. Make sure that's clicked. Make sure it's actually updated here. Everything should be. You can open your plot versus time and do this real quick before you start, just in case. You can clear this. And then again, it starts at 30. The max we'll see is around 12 cc's. That's the biggest pore volume we have, so absolute. And then we'll change this to 0. And then our max RPM is going to be 7,000. Again, you don't have to change that, but I like to just keep it open. Keep it in the background, and then make sure you have your data in here for log continuous time, and then your log every time. So it's going to log continuously for 0.05 hours, and then after that, it's going to switch to log every half a minute. So we're just going to hit start. It's going to open up our Excel sheet here. We have our Excel sheet. And we have our graph. And it'll pretty much run like this until all the steps are ran through. As you can see, we have our produce volume down here on the graph. If you look, you have displacement percentage down here. These are pretty permeable samples, so they'll actually run pretty quick here. Capillary pressure, and then you have your produce volume for each cup. Like I said, so now we're cycling, as you can look down here, it's automatically cycling between 1, 2, and 3, and based off of this log continuous time, it's going to keep logging again for this amount of time, which is around 7 minutes. So for 7 minutes, it'll do this continuous, and then again, it'll switch to just looking at them every 3 minutes. It'll continuously look, but it's only going to log to this Excel file every half a minute. As you can see right now, it is in that continuous mode. And again, you can adjust those. You don't have to keep the 0.05 or the 0.5. You can do whatever you would like. But if you look at our cup 3, you can see that our yellow line here, or cup 1, I should say. Cup 1 is producing a lot more. So actually, we've almost displaced half of its pore volume right away, just in this step. So, but your other 2 cups are much slower. Like I said, 6%, 12%. So you have about a half a cc and 1 whole cc, but literally almost 6 cc's literally, and it's pretty quick now. Again, this graph is just a visual, but you can always switch this to a different time. So we switched to 10 minutes now. You can see that a little bit better. So if we wanted to say this is done producing, it's obviously not. It's still producing some. But if I were manually watching this and I didn't want to wait, if I set in a wait time, so if you actually look into your parameters, let's say you put in 5 hours here. So if we have 5 hours and at 4 hours we see that it doesn't produce anything more, you can always hit skip forward here. So it's going to skip to the next step. If I hit skip, it should go to our next step. And then, like I said, you might get a missed data point, depending. Yeah, like cup 1 just has a missed. It should be pretty quick. And then again, we should see a good amount of production come out of now this capillary pressure, which is 14.9. So this is the end of our test. It stopped over the night, and it will actually close the Excel sheet, like I said, but it'll keep the centrifuge actually running. And then you can kind of manually, if you wanted to run to the next step, you could do that if you wanted. As you can see, we produce 79%, 59%, 78%. So it won't produce everything, but. And then this is our graph to show us our produced production here. If you're actually done with the test, you can just hit stop. And the same thing, close. And then if you go into your actual computer here, go into your C drive, you go in the test data, and then we can look for our test here. So this is our actual test we started. And then this is all of our data. So this is after our drainage run. This is what you can see again. So everything down here is your water produced, and then your oil up here. So this is what came out of the rock, and then ideally what came out, oil went in. So you have that oil displacing water there. You can see this one actually, that oil is actually a little bit red. This isn't the first time we ran these samples, and that's some residual dyed oil from an imbibition test as well. And we'll go through the imbibition test, but you can see how this one actually produced the most, and then 3 was second, and then 2 didn't produce quite that much. I haven't looked at the data exactly, but that's what it looks like after the test for a drainage run. And then we're going to go through the imbibition test next. So this is our setup for the imbibition test. This is your receiving tube. This goes on top. This is what your actual core sample goes in. Just sits inside this cup. Your sample will go in there. This will sit on top, and then it'll all sit inside your tube like this. So it'll essentially kind of look like this. It'll sit inside just like that. And then you have a little O-ring. You have one O-ring. Well, you have 2 O-rings. You have an O-ring here and an O-ring here. This O-ring will actually seal. This will seal inside the cup here. That you can see like a little bit of a step in there where that seals at. And then you don't have any distribution plug or anything like that. The rock literally just sits like that. And then you also still have a screw for the top to inject things as well. So that's where you inject all your fluid at and that. So for imbibition, we're actually going to be using a dyed oil. And this is what we use. This comes with most centrifuge. This is oil red. So this is oil soluble. It won't actually go into the water at all. We're going to use this with a stir. So this is our same oil we use. The oil that's actually in the rock itself is clear. So we're going to put a highly concentrated dose of oil as our reference oil, and then it'll slowly get diluted as production of oil is produced. So the more oil that comes out of the rock will actually blend in with this initial amount of oil. So you want to make it kind of as dark as possible, because it'll slowly, like I said, get diluted. So it doesn't take much of this though. So like I said, the darker the better, but we'll let it run for a little while. And again, we'll probably use about 5 cc's for our reference volume again. So this is going to be the calibration for imbibition. Same thing, we're going to just manually put in, this is just regular, this is going to be your heavy fluid. So your brine or your water, whatever you're using. We'll fill this up just by hand with a beaker first. You can do this with a syringe when it's put together, but it's just faster to do it this way. And then we'll actually put everything else together. Okay, so you can set aside cups 2 and 3 right now after you've filled up your initial amount of water there. You're just going to use cup 1, and you're going to fill it up about 3/4 of your actual tube. So if you look at the graduations, that's where the actual window is. That's the actual window right there when it sits inside there. So anything above this, you won't be able to see. So 3/4 of here. So if this is a 23 cc, we're going to bring the water up to about here. So, and then we're going to put 5 cc's of oil on top there. So we'll go about there. So this is a little bit tricky, but once you've got your water in there, we know we want to add, like I said, that 5 cc's of our dyed oil. This is going to be for our calibration. Again, so this needs to be exactly 5 cc's. It's going to be tough because when you start touching the outside of that, it's going to change the weight. So the key is to not touch the side wall as you're going in. I know it's very difficult, but like I said, the idea is just really not to touch that. So if you kind of know the density too and what 1 drop, so if you watch for that 1 drop to fall in, this should be about 0.02 or so. So if you can look through the top as you're going down and you watch that 1 drop, it should be okay. So we'll say that's pretty close. So once you have your volume in there, you're going to actually tare this weight. And then your other 2 that we started, you're actually just going to use just water for these. And then you'll add that essentially 31.7 cc's. We're only calibrating with 1 tube, so these ones don't need actually oil in them. Okay, so again, we know that we need to fill up to have the equal weights for all of them. And we know we have to do 31, so you might as well just take whatever size syringe you have. You don't need it on the scale. You know, you need to do this and just fill it up like this. Yep. And you'll do the same for the last one. About 29. So they'll look something similar to this when they get done. So we just switched now. This is going to be our imbibition test. If you notice, if you look up and you can see the picture, it's all black right now because we still have to adjust our camera. We have to adjust our camera to go over more. So we'll just adjust this axis now. We're going to adjust it over to the right. Most likely, you're going to have to bring it all the way over. You should be able to see the entire cup. So cup 1 is the one with our actual oil. As you can see right about there is, you can see each line of the cup now. You can see the oil in there. It's kind of dim, but we can adjust that. So here's a little bit closer of a shot of that. Again, cup 3 is empty, cup 2 is empty, and then our cup 1 now. So this is our little bit of 5 cc's of oil. You can see that this side is kind of bouncing up, and that's not amazing quality. And we can adjust that. So your light intensity is 75. It's probably not going to be that high. We're going to take it down to 25%. See what that looks like. And that actually darkened it up quite a bit. You can see our light interface. So for the imbibition, you absolutely need the heavy and the light interface. You can see light interface is 0. Heavy is around 5500. For imbibition, you have to have both because we're actually going to be measuring the distance between these two fields. And like I said, so this area is actually going to grow now with production. So your rock would be down here, and this is all the water, and this water is going to be forced down into the rock, and then everything coming out of the rock is this oil, and it'll actually be going through and actually be getting, it'll be growing. So the heavy and the light interface will actually separate. That being said, we need to adjust the ROI start and end. So the end now, this is 7,000. It's probably going to be more like 8,000. So we adjusted this to 8,000, and it did pick that up. But you'll have to do this for all 3 cups. So again, for the other cups, you'll have to do the same. This one's already set at 8,000, and then probably 1,000. That the 1,200 is probably good. And then also 3 is already set for 8,000 as well. 1,200. The main thing for the ROI start and end though is going to be, you really want the entire cup, but you don't want to catch any of these little like gray spots right here. So again, 1,000 should be good. 1,200 is fine. We're not going to be anywhere near that. So now to run the imbibition, we're going to go into test configure. You have to go into the rotor parameters, and we're going to be doing the 23cc imbibition. So first you have to go here, hit save, close, and then you can go into your calibration factor. Now it's switched over to imbibition over here. We already have some data in here. We have 3 cc's in here. We're going to adjust, we put 5 in. So this is a crucial step, by the way. Make sure you have the right volumes in. So that we're saying this is a known volume. So now this amount of pixels is going to be our 5 cc's. So you're going to go into your calibration factor, and again, it is your heavy and light. Again though, your light interface is still going to be based off of your test criteria here. So when you do your auto parameters, it's still going to be this number. So actually it's 20% right now, 20, 25. You can just put 25 in here because that's what we're at, but let's see what 20 does. With imbibition, you don't want as strong of a light either, because this oil is going to get diluted because the oil in the sample right now is clear. So you have to always take that in consideration. So we're still pretty close to the 5 though. You could adjust it slightly, but we're going to leave it for now. And then you would change those numbers now for every single step. So wait for this to stabilize. I think this is 35. Let's look at it. Oh, 25. So this is your 25. Again, you could change it. You could leave it at 20. You just have to adjust the other one. Whatever gives you a good image. Actually, that's not a great image, so we'll see what 25 does. See, even that's a little dark. So maybe we want to do 30. Cleaned it up a little bit. Let's see what 35 is. Yeah. So actually 35 is probably more like what we're going to do. So in the auto, we're going to actually change this to 35. Save it. And then we'll put in our calibration factor now for 35. And then save. And we're close, but a little off. I'm going to adjust it again. Oops. Yep, and much closer. And again, you just do this all the way for your entire test. If you're going up to 10,000, you go to 10,000. If You're going to, right now, this is probably 7,000. We're going to go all the way up to 7,000. So this is the samples right after our drainage test, already saturated with our oil. You'll have to dab them off a little bit. You don't want any of the oil that's on the outside of the rock. You just want what's inside the rock. But you're going to do the same thing. You're going to take your brine water and you're going to fill them up. You might want to use a syringe, but you should be able to pour some around there. Probably have to do it a few times. Okay, so you're going to fill up again with water, your brine, 3/4 of the way, and then we're going to put 4 cc's of oil at the top, and that's going to be our reference volume to start off with. And then we'll put that 4 cc's into the software. And then we're going to inject our 4 cc's of oil, again, for our reference on the top, and we use a scale for that as well. So after we've put our 4 cc's of oil in there, we weighed those out, so those should be all the same weight, but we didn't weigh our water. We just kind of guesstimated essentially 3/4. We need to weigh each core by itself to make sure they're all the same weight. So again, the same as the drainage, you're going to weigh each one at a time, and then you'll take the heaviest one. Okay, so when you do the lead for the imbibition, you're going to set it on the top of the actual receiving tube there. So again, make sure your graduations are not in the window. And then it's a bit tricky on how to actually install this without that falling off. But the idea is you're going to tilt your actual rotor sideways. So you actually tilt it up and down, and you'll actually screw in the rotor from the bottom, or you'll screw in your cup from the bottom. Then our last cup. And then remember to put your windows straight up and down. So the first thing you're going to do, again, same as drainage as imbibition, is you're going to check your log file here. Go into custom all files. I already created one. So this is going to be the imbib one I created. So imbib 121, I just put the date. You can obviously put whatever you'd like, but that's what I'm using. And then again, you're going to go double check your auto parameters. I haven't changed anything, so it's the same criteria, same everything. And then your user parameters here. And most of this shouldn't change either because we're running the exact same samples. Same fluids, just reverse. Everything should be pretty much the same. We started with the 4 cc's instead of 5 cc's, but that's the only difference there. I already changed that, but pour volume and everything like that, and this, like I said, should all be pretty much the same. And again, I'm going to use the same auto test criteria too. Okay, so now I'm just starting the imbibition test. I clear this first. And then just hit start. And then it'll automatically open up the Excel sheet there. And then it'll auto-populate for 1, 2, and 3. So for imbibition, it takes a little bit to stabilize, as you can see here. Just because the buckets are sticking out further, takes a minute. If we switch this now to a longer time period for this graph, you can see the red and the blue. That's going to be cup 2 and 3, and you can see how they missed. So the software started to log it before it was actually stabilized. So you just delete those as dead points in your Excel sheet. And this is the Excel sheet it's updating. It's going to log each one. And we can switch this from 2 minutes to 10 minutes, and then give it a second and it'll update it. And then you can kind of see our production there in real time. So for the sake of this not being super boring, I've sped this up quite a bit. But this is just the beginning of, like I said, the imbibition test, and it's going to run like this for probably 24 hours or so. But this just gives you a little idea of this is the first step in the run. And like I said, this is sped up like 400%. And switching through the cups incredibly fast, as you see. And this is the same. We're still in step 1. And I've also sped this up. This is just midway through step 1. But you can see the production there. So as you can see here, the cup 1, it's missed a few. As you see it scroll through, you can kind of see it's a little bit hazy. It's caught it now, but all those peaks up there are dead points as well. So you delete all those. So here is step 2. You can also see some dead points. Obviously, when it switches between each step, you get a dead point. But same with drainage. But yeah, this is step 2. So this is the next morning. The test is all over with. The Excel sheet will close, but the centrifuge will keep running. And that's if you wanted to do another run, you could always add on the next step and then hit start, and you wouldn't lose anything. This is our graph here. You can see how much produced volume we have. Maybe could run a little bit longer, but for this experiment, it's pretty good. If you look at our graph here, bring it back, you can see one of those steps lost a lot of points there. Must have been kind of a bad image, which could have been from our setup or something, light intensity or something like that. So that's pretty much it for the imbibition test.